Welcome back to our Chem 152 video series. In this video, we'll balance redox reactions. Below is an unbalanced redox reaction consisting of two half reactions. Our first task is to balance the manganese half reaction in acidic solution. Notice that in this reaction we have pieces that have manganese and pieces that have nitrogen. On the left we have manganese 2+, and on the right we have MnO2. We'll deal with the manganese pieces first. We'll just write that we'll have Mn2+ on the left, yielding MnO2 on the right. In order to balance this, there are four tasks we have to accomplish. First task is to balance the manganese on both sides. Our second task will be to balance the oxygens on both sides by adding water to whichever side has less oxygen. The third step will be to balance the hydrogen on both sides by adding H+ to the side with less hydrogen. The fourth step will be to balance the charges by adding electrons to whichever side has the more positive charge. Let's go through these steps one by one. For the first step, we may notice that we have one manganese on the left and one manganese on the right. Therefore, we don't have to make any adjustments to the manganese since there is one on either side. We'll check that off. Second step, we now balance the oxygen by adding water to the side that has less oxygen. On the right, we have 2 oxygen, and on the left, we currently have no oxygen. This means we need to add 2 waters onto the left. When we add 2 waters, we add 2 oxygen. That makes the oxygens equal. 2 on the left now, and 2 on the right that we already had, equalizing the oxygen. Next, we look to the hydrogen. On the left, since we added 2 waters, we now have 2 times 2 hydrogen, or 4. On the right, we start with no hydrogen. Therefore, we will need to add 4H+ onto the right side to balance the hydrogen. This balances our hydrogen, and we'll check off step 3. Now let's look to our charges. On the left, we have no charge from water and a 2 positive charge from the manganese, giving us a charge of 2 on the left. Now on the right, we have 4 pieces of H+, and so we have 4 times positive 1 equals 4. Now we hit pause and look at which side is more positive. Since the left has 2 charge and the right has 4 charge, we're going to have to modify that 4 to make the charges equal. The difference between 4 and 2 is a difference of 4 minus 2. 4 minus 2 gives us a difference of 2 electrons. And so we're going to need to put 2 electrons on the right side, since that's the side that was more positive. So, along with the MnO2 and the 4H+, we're going to put 2 electrons on the right. This completes our task of balancing this half reaction. Now we'll ignore the manganese and look to the nitrogen. We'll perform the same steps that we did previously. As a reminder, our first step is to balance the nitrogen. Then we will balance the oxygen by adding water. We'll also balance the hydrogen by adding H+. And then we'll balance the charges by adding electrons. We'll write the left side and the right side. First, we look to the nitrogen. We have 1 nitrogen on the left, 1 nitrogen on the right. Therefore, our nitrogen is already okay, and we don't need to modify it. Now we look to the oxygen. On the left, we have 3 oxygen, and on the right, 1 oxygen. Therefore, we're going to need 2 more oxygen on the right side. To do that, we will say plus 2 waters. This will give us the 2 oxygen we need. Now we look to the hydrogen. On the left, we have no hydrogen. On the right, we now have 2 times 2 for 4 hydrogen. This means we're going to have to add 4 hydrogen onto the left. To do this, we will add 4 pieces of H+. Now we look to our charges. On the right, we have nothing that's charged, therefore the charge is 0. On the left, we have 4 H pluses for 4, and then a negative NO3 minus 1 gives 3. Therefore, the side that has a higher charge will need the electrons. Since we have 3 and we want to go down to 0, we will need 3 electrons, and we'll also write that. Therefore, this is our balanced nitrogen half reaction. Now that we've written 2 reactions, we'll combine them together to make a balanced complete reaction. However, the number of electrons in each line is different. Notice in line 1 we have 2 electrons, and in line 2 we have 3 electrons. We must make sure that the electrons match. Therefore, to make the electrons match, if we have a 2 in line 1 and a 3 in line 2, we're going to go for a total of 6 electrons. So we'll multiply line 1 by 3, and we'll multiply everything in line 1 by 3. This will give us our target of 6 electrons. Likewise, we will multiply line 2 by 2. Taking into account that we started with 3 electrons, we'll say times 2 to everything in line 2. And now we'll write our new line 1 and line 2. Line 1 will now be 2 water times 3 makes 6 water. Mn2 plus times 3 makes 3 Mn2 plus. Yields 3 MnO2 plus 12 H plus 6 electrons. Line 2 will also change because we'll multiply everything by 2. We now have 6 electrons. Then 2 times 4H plus is now 8H plus. 2 times NO3 gives 2 NO3. We'll note that it's negative. Yields now 2 pieces of NO and 4 waters. Now we'll draw a line to separate the left from the right and try to cancel out whatever we can. First, we'll note that our electrons are going to be 6 on the left and 6 on the right. Those are located at these red marks. Since they're exactly the same, they will cancel. Therefore, our overall reaction will not contain any electrons. This is what we want to happen. Notice also we have water on the left and water on the right, but not the same amount. There are 6 waters on the left, 4 waters on the right, and that is a difference of 6 minus 4, or 2 waters. But since the left side is the one that's higher, the remaining waters will go to the left. We also have hydrogen on both sides. If we look to the yellow marks, we see that there are 8 hydrogens on the left, 12 hydrogens on the right. That is a difference of 12 minus 8 for a remainder of 4. However, since the right side has more, these 4 hydrogens will go to the right. Let's make the modifications to this equation. We will cross out the 4 waters on the right and reduce the 6 waters on the left to 2. We also have to modify our hydrogen. That means the 8 hydrogens on the left will cancel, and we will change the 12 hydrogens to 4 hydrogens. Let's write down what we have left, starting from the left side. We have 2 waters. We have 3 Mn2 plus and 2 NO3 minus. On the right side, we now have 3 MnO2, 2 NO, and 4 hydrogens. And these 6 terms will make our complete balanced equation. You may also be asked to modify the reaction equation to show what would happen in basic solution. What we need to do in basic solution is exchange the H pluses for OHs. We'll first identify where the H plus is located in the equation, and what we'll do is add an equal number of OHs to that. We'll do that on both sides. Since we have 4 H pluses in the equation, we'll add 4 OH minuses to both sides. What we need to notice is that when you add H plus to OH minus, those will react together and give you 4 water. Therefore, when we modify this equation, most of the reaction will stay the same. We'll still have 3 Mn2 plus, 2 NO3 minus, 2 water, and now 4 OH minuses. That's all on the left. This will yield 3 MnO2 plus 2 NO plus now 4 water where the H plus once was. The only thing left to do now is cancel down the waters. On the left, we had 2 waters. On the right, we now have 4 waters. Therefore, we look at the difference between those and take 4 minus 2, giving us 2 waters left over. Since the 4 is on the right side and that is the higher number of waters, that means the remaining waters will be left on the right. So we'll modify this 4 waters down to 2 waters, and we will cancel out the 2 waters on the left. Therefore, our final equation again looks fairly similar to this. We still have 3 Mn2 plus. We still have 2 NO3 minus. We no longer have the 2 waters on the left, but we do have 4 OH negative. This will yield 3 MnO2 plus 2 NO plus 2 water. And so these 6 terms will give us our base version of the same reaction we found for the acidic version. So if you ever need to modify an acidic version to a base version, this is how we handle it. You may also be asked to find the standard reduction potential for the reaction. What we need to do is identify which reaction is forward and which reaction is reverse. First, we look to the manganese. In the reaction we start with Mn2 plus and yield MnO2. But you may notice this is exactly the opposite of what's in the table. In the table, we go the other way. The table says MnO2 yields Mn2 plus, and that means this first version was reversed. If we reverse what's in the table, that gives us our actual reaction. And remember that if we ever have to reverse a reaction, we must also reverse the reduction potential. Therefore, the potential for this reaction that we actually did is not plus 1.23, it is now negative 1.23. Because we reversed the reaction, we must reverse the potential as well. Now we look at the NO3. In the reaction we have NO3 negative yields NO. In the table, we have NO3 negative yields NO, and so this one is written normally, forward. Therefore, we make no change to the potential. Therefore, our potential for this reaction will be 0.957 minus 1.23. This will give us negative 0.273 volts for our potential for this reaction. This will be our E standard. Since the E standard is negative, the reaction we've written is slightly unfavorable. Thank you for watching, and we'll see you again soon.